The 3x plus 1 problem, 63,728,127, my mega favorite number. The Collatz conjecture is where you take any positive integer and repeatedly apply these two rules. First, if it's odd, multiply by 3, then add 1. If it's even, divide by 2. Then just continue this forever. The question that Collatz asks is, does every number reach 1 eventually? You can see from this tree that most numbers seem to go down towards 1. And then once you reach 1, you can see at the bottom there's a loop. It stays at 1. The question is if there's any other loops out there like this. Well, it's conjectured that all numbers will eventually reach 1, but some numbers do seem to take an especially long time. Powers of 2 go to 1 the fastest because they can just keep being divided by 2. And to measure how fast a number goes to 1, we can have a ratio n to s, where n is the number and s is the number of steps that number takes to go to 1. In fact, to make it even easier, we can change the number to log base 2 of the number. This makes it so that all the powers of 2 have a ratio of exactly 1. Then, the longer that a number takes to reach 1 relative to its size, the closer the ratio gets to 0. I decided to make a program to look for numbers with a low ratio. What my program does is it just checks every single number, goes through the Collatz process to figure out how many steps it takes to go to 1, calculates the ratio, and then if the ratio is lower than any number it's found before, it will print it out. Here's the final code that I wrote. This part is just doing those steps that were shown earlier. If it's even, divide by 2, odd, multiply by 3, and add 1. This is just adding the results that it gets to lists so that it can record the numbers and the ratio. This actually executes it, going from starting with numbers that are really small and then checking out to really large numbers to see their ratios. This puts it into a spreadsheet, and then finally, this prints out all the ratios that are the smallest ratio yet. Here's what happens when I run my code. It prints out all the numbers that it found, then it generates this spreadsheet, and you can see in the spreadsheet it shows you every number, how many steps it took to get to 1, and then the ratio. I started to slowly increase how many numbers I checked. Here are the final results I got. The number with the lowest ratio I found was 63,728,127, my mega favorite number, and its ratio was approximately 0.027. But there's almost certainly a number with a lower ratio. The link to my code is on the screen and in the description. See if you can find a lower ratio number.